Hello everyone. So in this class, let us solve the exercise 3.1. First question, in the matrix A. So write first question, the order of the matrix. Second, the number of elements. Third, write the elements. We have to write the elements. So first one, order of the matrix. We know that order of the matrix means number of rows by number of columns. So the given matrix has 3 rows and 4 columns. So the order of the matrix becomes 3 by 4. Second one, the number of elements. The number of elements will be, so we have seen, suppose A is the matrix of order m by n, then the number of elements will be m into n. So here order of the matrix is 3 by 4. So the total number of elements will be how much? That is 3 into 4. We will get 12. Third one, we have to write the elements A13. So see here. So these are the rows. First row, second row, third row. These are columns. First column, second column, third column, fourth column. A13 means the element lies in first row, third column. So if you see the element in first row, third column, so this is the element. The value is 19. Similarly, A21 value is, so we have to find the element which lies in second row, first column. So this is the second row, so this is the first column. So the value of A21 becomes 35. A33, so that is third row, third column, third row, third column. So the value becomes -5. A24 means second row, fourth column. So this is the second row and this is the fourth column. So the value becomes 12. Next, A23. So that is the second row, third column. So this is the second row. So this is the third column. So the value becomes 5 by 2. Second question. If a matrix has 24 elements, what are the possible orders it can have? What if it has 13 elements? So we have seen, suppose consider the matrix of order m by n, then the total number of elements will be m into n. So this we have seen. So here it is given that the matrix has 24 elements. So what we have to find? We have to find the possible orders it can have. Means here we have to find the ordered pair of natural numbers whose product is 24. So find all the pair of natural numbers whose product is 24. So one is 1 comma 24. We know that 1 into 24 is 24. So the order, so what are the possible orders? One order is 1 by 24. Similarly, 2 into 12, we have 24. So 2 by 12. Similarly, 3 by 8, 4 by 6. Next, 6 by 4, 8 by 3, 12 by 2, as well as 24 by 1. So these are the possible orders a matrix can have with the 24 elements. So next one. So we have to find the possible orders if the matrix has 13 elements. Similarly, so 13 elements means, so one order will be 1 by 13 as well as 13 by 1. So these are the only two possible orders if the matrix has 13 elements. So next one, third question. If a matrix has 18 elements, what are the possible orders it can have? What if it has 5 elements? Again, here also we have to find ordered pair of natural numbers whose product is 18. So one is 1 comma 18. So order will be 1 by 18. Similarly, 2 into 9 we will get 18. So order becomes 2 by 9, 3 by 6, 6 by 3, 9 by 2, and 18 by 1. So these are the possible orders a matrix can have if it has 18 elements. So next one. What if it has 5 elements? If it has 5 elements, so what are the orders? That is 1 by 5 as well as 5 by 1. Fourth question. Construct a 2 by 2 matrix A is equals to Aij, whose elements are given by, first one, Aij is equals to I plus j whole square by 2. Second one, Aij is equals to I by j. Third one, Aij is equals to I plus 2j whole square by 2. So we have to construct a 2 by 2 matrix. Solution. We know that the general form of the 2 by 2 matrix. So 2 by 2 means it has 2 rows and 2 columns. So the elements of the 2 by 2 matrix is given by A11, A12, A21, A22. So if you solve the first question, they have given Aij is equals to I plus j whole square by 2. So let us find the value of A11. A11 is equals to, see here, Aij means I plus j whole square by 2. So A11 value becomes 1 plus 1 whole square by 2. So that is equals to 2 square. 4 by 2 becomes 2. Next element A12 value becomes 1 plus 2 whole square by 2. So that is 9 by 2. Then A21 is equals to, here I value becomes 2, j value is 1. So 2 plus 1 whole square by 2. So that is 9 by 2. Next A22 means I value is also 2, j value is also 2. So 2 plus 2 whole square by 2. So that is 16 by 2. That is 8. So if you substitute the values, so what we will get? A11 means 2, 9 by 2. A21, 9 by 2. A22 means 8. So this is the first question. Second one. So here they have given Aij is equals to I by j. So the value of A11 becomes, see, I value is 1, j value is also 1. So that is 1 divided by 1. So the value of A11 becomes 1. A12 becomes 1 by 2. Next, A21 means I value 2, j value 1, that is 2 by 1. The value becomes 2. A22, that is 2 by 2, that is equals to 1. So the required matrix, so what is the required matrix? 1, 1 by 2, 2, 1. So this is the required matrix of order 2 by 2 with the elements Aij is equals to I by j. Third one, Aij is equals to I plus 2j whole square by 2. So the element A11 becomes, A11 is equals to I value is 1, j value is also 1. Substituting the values, what will get? 1 plus 2 into 1 whole square by 2. So that is 3 square by 2. So we get 9 by 2. Next element A12. A12 means I value 1, j value 2. So what will get? 1 plus 2 into 2. 4 whole square by 2. So that is 5 square, 25 by 2. Next element A21. So here I value 2, j value 1. Substituting 2 plus 2 into 1, that is 2 whole square by 2. 4 square, 16 by 2, value is 8. Next A22. A22 means I value 2, j value is also 2. So what will get? 2 plus 2 into 2. So that is 4 whole square by 2. 6 square, 36 by 2. We get 18. So the required matrix will be 9 by 2, 25 by 2, 8, 18. Fifth question. Construct a 3 by 4 matrix whose elements are given by, first one, Aij is equals to half of modulus minus 3i plus j. Second one, Aij is equals to 2i minus j. Solution. So the order of the given matrix is 3 by 4. Means it has 3 rows and 4 columns. So the general form, suppose if you consider the given matrix as A, so the general form of the given matrix will be A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34. It has 3 rows and 4 columns. Also they have given Aij means half of modulus minus 3i plus j. So let us compute the elements. First A11. A11 means what we will get here. Substitute I is equals to 1 as well as j is equals to 1. Half of modulus minus 3 into 1 plus 1. So that is equals to modulus of minus 2. We know that modulus of minus 2 is 2. 2 by 2 becomes 1. So modulus of negative quantity is always positive. So next A12 is equals to, substitute I is equals to 1, j is equals to 2. 1 by 2 into minus 3 plus 2. So that is modulus of minus 1 becomes 1. So 1 by 2. A13. Similarly, what we will get? 1 by 2 modulus minus 3 plus 3. So that is 0 by 2 becomes 0. A14. 1 by 2 mod of. So minus 3 into 1 plus 4. So what will we get? 1 by 2. So these are the first row elements. Similarly, let us find the second row elements. A21. So substitute I is equals to 2, j is equals to 1. So that is equals to half of what we will get? Minus 3 into 2. So that is minus 6 plus 1. So mod of minus 5 becomes 5. 5 by 2. Next A22. Half of I is equals to 2, j is equals to 2. Minus 6 plus 2. So mod of minus 4 is 4. 4 by 2 becomes 2. A23. 1 by 2. Minus 6 plus 3. So that is 3 by 2. A24. 1 by 2 times minus 6 plus 4. So mod of minus 2 is 2. 2 by 2 becomes 1. So these are the second row elements. Next, third row elements. A31. I value will be 3. J value is 1. So substituting 1 by 2 mod of minus 3 into 3 becomes minus 9 plus 1. So mod of minus 8. Mod of minus 8 is 8. 8 by 2 becomes 4. Next element A32. 1 by 2 into mod of minus 9 plus 2. So that is 7 by 2. A33. 1 by 2 into modulus minus 9 plus 3. So that is mod of minus 6 becomes 6. 6 by 2 becomes 3. A 3 4 1 by 2 mod of minus 9 plus 4. So that is mod of minus 5 becomes 5 by 2. So these are the elements. Now writing all the elements. So first row elements 1 1 by 2 0 1 by 2. Second row elements 5 by 2 2 3 by 2 1. Third row elements 4 7 by 2 3 5 by 2. So this is the required matrix of the order 3 by 4, whose elements are given by Aij is equals to half of modulus minus 3i plus j. So similarly you can find out this matrix also, whose elements are given by Aij is equals to 2i minus j. So you can solve similar way. So this is the general form. By taking suitable I and j values, find out the elements a1 1 2 a3 4. Then write all the elements, you will get the required matrix. So sixth question, find the values of x, y and z from the following equations. So first one, matrix 4 3 x 5 is equals to matrix y z 1 5. So solution. So we know that two matrices are equal, means they should be of the same order and corresponding elements are same. So if you see, both the matrices are of the same order. So if you equate the corresponding elements, we can find the values of x, y and z. So here y value becomes 4. Z value becomes 3 and x value becomes 1. So directly equating the corresponding elements, we can find the values of x, y and z. So second one, here also we have to find the values of x, y and z. So equate the corresponding elements. So we can see that x plus y value becomes 6. So similarly 5 plus z value becomes 5. And x into y value becomes 8. So 5 plus z is equals to 5. Implies what? Z value becomes 5 minus 5, or z value becomes 0. So from these two equations, we have to find the values of x and y. So first equation, we have x plus y is equals to 6. So that is x plus. So from the third equation, we can write y value becomes how much? Y is equals to 8 by x. So in case of y, so what I can write? I can write it as 8 by x. So x plus y means from the third equation, y value becomes 8 by x, that is equals to 6. So simplifying, x square plus 8 is equals to 6x, or x square minus 6x plus 8 is equals to 0. So this is a quadratic equation. So if you solve this quadratic equation, so x square, so here we have 8 here, coefficient of x as -6. So we have to find the numbers whose product is 8 and sum is -6. So we can take the numbers as -2 and -4. So the same equation we can write it as x square minus 2x minus 4x plus 8 is equals to 0. So that is, if you take x common from first two terms, x into x minus 2, by taking minus 4 common from next two terms, minus 4 into x minus 2 is equals to 0. Again taking x minus 2 as common, that is x minus 2 into x minus 4 is equals to 0. Or x value becomes how much? X value becomes 2 or 4. So the required solution, see here, x is equals to 2. When x is equals to 2, y value becomes how much? See, x plus y is equals to 6. So when x is equals to 2, y value becomes 6 minus 2. So that is, y value becomes 4. And z value, already we obtained the value of z as 0. So this is the one set of solution. Otherwise, when x is equals to 4, y value, when x is equals to 4, what happens? Y value becomes 6 minus 4, that is, y value becomes 2, as well as z value is 0. This is the another set of values for x, y and z. Third question. So here also equating the corresponding elements, we get x plus y plus z is equals to 9, x plus z is equals to 5, y plus z is equals to 7. So consider the equations as 1, 2 and 3. Now we have x plus z means how much? X plus z value is 5. So if you substitute the value of x plus z in the first equation, so x plus z value is how much? X plus y plus z is equals to 9. But x plus z value is 5. So 5 plus y is equals to 9. Our y value becomes how much? Y value becomes 9 minus 5, that is 4. So similarly, if you substitute the value of y plus z in first equation, so we have x plus y plus z is equals to 9. But from the third equation, y plus z means 7. So in place of y plus z, I can write it as 7 is equals to 9. So x value becomes 9 minus 7, that is, x value becomes 2. Now we got the value of x and y. Substitute the values of x and y in first equation, or you can substitute the value of x in second equation. So we have x plus z is equals to 5. X value is 2. 2 plus z becomes 5. Z value becomes 5 minus 2, that is 3. So these are the required values of x, y and z. Seventh question. Find the value of a, b, c and d from the equation. So they have given two matrices of the same order. So since they are equal, we can equate the corresponding elements. So equating the corresponding elements, we have a minus b value becomes minus 1. Similarly, 2a plus c value becomes 5. 2a minus b is equals to 0. 3c plus d is equals to 13. So if you want, you can consider this as equation 1, 2, 3 and 4. So if you consider equation 1 and 3, so what we can write, a minus b is equals to minus 1. Similarly, 2a minus b is equals to 0. So solving these two equations, so subtracting one from another, so minus b plus b will get cancelled. A minus 2a, so that is minus a is equals to minus 1, or a value becomes 1. So since a is equals to 1, substitute the value of a in first equation. So that is 1 minus b is equals to minus 1, or b value becomes 2. So taking minus 1 to LHS and minus b to RHS, we get the value of b as 2. From second equation, already we know the value of a. Substitute the value of a in second equation. So that is 2a plus c is equals to 5. So if you substitute a is equals to 1, so what will we get? 2 into 1 plus c is equals to 5. C value becomes 5 minus 2. That is c value becomes 3. So once we get the value of c, substitute the value of c in fourth equation. So that is 3c plus d is equals to 13, or c is 3. So 3 3s are 9 plus d is equals to 13, or d value becomes 13 minus 9, that is 4. So these are the values of a, b, c and d. So 8th question, A is equals to Aij m by n is a square matrix if options are m less than n, m greater than n, m is equals to n, none of this. So we have seen that square matrix means number of rows and columns should be same. So here, so this is number of rows, this is number of columns. So since both should be same, the correct option is option C, that is m is equals to n. So next question, 9th one. Which of the given values of x and y make the following pair of matrices equal? So there are two matrices. We have to find the values of x and y such that these should be equal. So equating the corresponding elements, so we can write 3x plus 7 is equals to 0. Our x value becomes, so 3x is equals to minus 7. Our x value becomes minus 7 by 3. Similarly, if you equate these two elements, so what we will get? 2 minus 3x is equals to 4, or so taking 4 to LHS, 3x to minus 3x to RHS, so we get 3x is equals to 2 minus 4, that is minus 2. Our x value becomes how much? Minus 2 by 3. So we got two different values for x. So what we can conclude, it is not possible to find the values of x and y. So correct option is option B. Here we have not got the unique value for x. 10th question. The number of all possible matrices of order 3 by 3 with each entry 0 or 1 is, options are 27, 18, 81, 512. So 3 by 3 matrix means it has total 9 elements. So that is we have the elements A11, A12, A13, A21, A22, A23, A31, A32, A33. Total we have 9 elements. So here they have given at each entry we can put either 0 or 1. Means at each position we have two options, either we can put 0 or 1. Similarly, at all the places we can put 0 or 1. So we have two possible cases. So therefore total number of possible matrices. So what is the total number of possible matrices? So if you multiply all these values, that is 2 into 2 into, so what we will get? There are 9 2's, so we can write it as 2 power 9. So 2 power 9 is 512. So there are 512 possible matrices we can form of order 3 by 3 with each entry 0 or 1. Suppose we have to form 3 by 3 matrix with each entry 0, 1, 2 means what happens? There will be 3 chances at each place. We can write 3 into 3 into like this. So total number of possible cases becomes 3 power 9. So this is, so the right option is option D, 512. So this finishes this exercise. Thank you.